Okay, so welcome back. I wanted to give you guys a few examples of using vectors in the way we will be using them. Okay, so so for my first example, I have that we're walking in a direction, a bar, so that's our vector, for 5 kilometers at an angle theta equals 30 degrees, and we want to know the x component of a bar. Okay, so let me go over here to my whiteboard and I will show you guys how we can figure this out. Okay, so again, we have our direction that we're walking is A equals 5 kilometers at some angle of 30 degrees. So the first thing I'm going to do is draw in a reference for myself. Okay, so this is going to be my y-axis and this is going to be my x-axis. Okay, and then I'm going to put in my vector at about 30 degrees. Okay, so there is my angle and there is my vector. Okay, and again, we want to find the x component of our vector A. So what we will do is what we were talking about in the last slide, the last video. Okay, I'm going to see where my A of x would be. That would be here. Okay, and my A, I know that it is 5 kilometers. Okay, so now I want to use some trig. Again, use my trig identities to figure this out. Okay, so I know my hypotenuse, A, okay, and I want to know my adjacent side. Okay, so I know we have our adjacent side, or we want to know our adjacent side, and we know our hypotenuse. Okay, so when you go back and think of your trig identities, which trig identity will we use here? Adjacent divided by hypotenuse, AH. Ca, right? So cosine theta, okay? So I will put this in. We have cosine of 30 degrees equals our adjacent, which is AX, divided by our hypotenuse, which is A. Okay, and then using some algebra, we can solve for our AX. So our AX equals A cosine 30 degrees, or theta. And then we can plug in our A as 5 kilometers. Solve for AX equals 5 times cosine of 30 degrees. And we can use our calculator. Okay, so we have 5 times cosine of 30. And that is going to be 4.33 kilometers. Now would be a good time to check and make sure that your scientific calculator is in the correct mode. Just make sure that is in degrees mode, because we are putting degrees in our trig function, okay, in our cosine, in our sines. We are putting degrees. So just make sure your calculator is in the degree mode, okay? So going back to our PowerPoint, okay, I have another example, okay? So we have a car. Hopefully you guys can see this. We have a car that's traveling 20 kilometers north, and then it travels 35 kilometers at 60 degrees west of north, okay? So let me scroll down here. Okay. So again, we have 20 kilometers north, and we can call this vector A, okay? Start designating. And then the next one is traveling, or then it travels 35 kilometers, 60 degrees. So we have 35 kilometers at 60 degrees west of north. Okay, and then we can call this B. Okay. All right, so we want to first look at this graphically, or actually that's all we want to do right now. Okay, so what we will do is we will say, okay, our A is in the north direction. Now, first we need to designate that. So let's say north is up, south, east, and west. Okay, and we will say we have our A here. Okay, and then we have our B. So we want to know what is going on here. So we're going to add these together. And this says 35 kilometers, 60 degrees west of north. Okay, so what that means is, again, we can have some kind of reference here, okay, and say that this is our north, and according to this, this would be our west, okay, and 60 degrees west of north. So I'm going to put this guy right about here. Actually, it's a little bit too far up, probably about there. Okay, because this is what it means by our 60 degrees west of north. Okay, this is the angle we're looking at here. Okay. Oops, there we go. Okay, so now we have our A and our B, and we want to look at this graphically. So we're going to do what we did before. So we have our A, and adding B, we are going to use the tip to tail method yet again. Okay, and this may not be perfect, it's probably far from it. Okay, but this is what we get graphically, and then of course we want our resultant vector right there. Okay, so this is what it looks like graphically. All right, now let's go back to our PowerPoint. And the next thing we want to try to do is solve this algebraically. Okay, so it's going to be a little bit different, okay, than solving it graphically. Okay, so let us scroll down and get some more space going. Okay, I have to have a nice clean slate here. Okay, so again we have, oops, we have R equals A plus B. I'm sorry for my handwriting, it's kind of terrible here. But now notice that we can break these down. So remember that each time we have a vector, okay, say, you know, A, we can break that down into AX plus AY, okay, like I said before. So if I want to add two vectors together, there's another way we can do this. We can now break this down into its components, Rx and Ry, and those two will now be composed of these X and Y components. So I'm gonna say Rx is equal to AX plus BX. And same thing with Ry. Ry is now AY plus BY. Okay? So we were given all of this information, okay? Our A is in the north direction, 20 kilometers. I'm just gonna copy it down here, north. Our B is 35 degrees, whoops, not 35 degrees, 35 kilometers, 60 degrees west of north. Okay, just copied that down here. And again, we can break down b to bx plus by. Okay, so now I need to solve for each of these components. Okay, I need to solve for my ax, my ay, bx, and by. Okay, so if I have my a, that is purely going in the north direction. Okay. And if this is my x, and this is my y, okay, and this is my a, it's only going in the y direction, okay, because this is north, remember? So I actually don't have an a, or I'm sorry, wow, messed that up a little bit. I don't have an ax component, I only have an ay component. Okay, so my a is really just broken down into ay, in that y direction, okay? And my ay is just going to be my 20 kilometers, since that's the only direction that it's moving in. So now I know my ay. My my b is gonna be a little bit more tricky, okay? So I have my b, okay? I need to solve for my bx and my by. And again, that's gonna be similar to what we did just a minute ago, okay? So we will kind of go like that, say that that's our by, and that this is gonna be our bx, okay? So I'm gonna start solving. Okay, we're gonna use trig again, okay? We want to know our bx, and this is also bx over here, remember that, same length, bx, and by. Okay, I know this is kind of getting a little bit messy here. Let me see here. Does not want to erase now. There we go. Okay, so what I will do is say, okay, I know my hypotenuse, okay, and that's gonna be our 35 degrees. I'm sorry, 35 kilometers, 35 kilometers. Okay, so I know my hypotenuse equals b, okay. I want to know both my bx and my by, so my bx is gonna be my opposite, okay. So I know my opposite is bx, and my adjacent is by. Okay, so to solve for these, I'm going to say opposite over hypotenuse. Which identity is that? OH, so that's going to be sine of theta. Okay, and so I know that's going to be my opposite, which is bx, over b, which is my hypotenuse. Okay, again, I can solve for bx like we have before. And now I can plug in my numbers, my b being 35, sine of theta, which is 60 degrees. Oops. Go. Plug that into my calculator. Again, remember that it needs to be in degree form. Okay, so now this is going to be 30.31, actually 30.3 kilometers. Okay, so that's my b of x. and bx. Okay, now I can do the same thing for by. by is going to be adjacent, so I know my adjacent, I need my adjacent, know my hypotenuse. So adjacent over hypotenuse is going to be cosine theta. by over b. Okay, do some algebra, solve for by. Okay, now we have by equals 35 cosine of 60. Plug that into your calculator and get 17.5 kilometers. Okay, so now what we'll do is we'll go back up to our resultant vector and figure out each of these components. Okay, so starting with Rx, we go back up here and we see that there is no AX component. Okay, so that's just 0. And we do have a BX component we solve for as 30.3 kilometers. Okay, so our Rx component is 30.3 kilometers. Our Ry is going to be our A component, our A vector, and our B in the Y direction is 17.5 kilometers. Okay, adding those two, we get 37.5 kilometers. Okay, so now we have each component of R. Okay, we have our Rx and our Ry. All right. So I think that'll be good for this couple examples. And then I will do some more and post those as well.